like to have is the Ipart, the question. This is the question which I previously answered. Say, ask you, your friends, your brothers, last year. This is the quiz for section 1. You can find this question in your assembly. The first thing, we would like to have a tabular part, which is called Ipart in inventor environment. And please make this sketch first of all. As you see, we have some parametric dimensions, and this is the way which we have just made the parts in the content center. I have separated my desktop into 2 pieces, and I will just create a new part file. Okay, open a new part. The first thing, we are going to start with standard millimetric IPT. If you have such a question, something like this, we all have the same question in every exam or quiz. Here, what I'm going to do is, I will just first make the model of the first row or second row or the third row. I will first design a part with the given dimensions here. Okay? The part is opening. As usual, please open the origin folder here. Make center point with right click, visible, and XY plane, right click, visible. Start a new sketch and select a plane to sketch on. As you see, we have 2 axis points. You can use this point here or this point. It is up to you. I'm going to use this point as origin. As you see, we have a circle here, and we have a hexagon centered at this point. And after this hexagon, the straight lines reach to this circle. First, I will just first make a circle, then choose a rectangle, then change it to polygon, and I'm going to make a six-sided polygon to this point. You can leave as it is, like this, with escape. Then I will just make this line as I see here with the vertical constraint. I get the vertical constraint and get this one. Okay. The next thing, I have another circle which is far from with LL length. For this, I will just connect these two circles with a center line, and I will just draw that center line and convert it to construction because I'm not going to use it. The next thing, I will just draw this circle. The next thing, I have connected these two ends, and I will change the top. Also change the other line, and I will make these lines and convert it with after the selection to construction. Okay, the next thing, I will just combine these two line ends. One line, just arbitrary lines. I'm not attached to this tangent because it is attached to this line. Have the constraint to this circle. You can make it a little bit smaller. Okay? Then trim the unnecessary parts. I do not need these parts. Also this one. Okay? For other side, you can again draw a line, or you can make a mirror command for the other side of the line. Have this line, have the mirror line, make the copy with apply, and done. Then you can make the trims. Okay? The next thing, I will just add the dimensions to our figure. The first thing, I'm just drawing the A 30 with LL length, which is 100. From this point to this point, it is 100. Okay, it's 100. Also, this S length or DD length. The DD length is, this is a diameter length. Change your dimension type to diameter. This is 30. The next, we have the RR length or DD length. As you see, it is the same. If you have made this one, this dimension, you can use the RR. Or if you want, you can have the DD line, which is the bigger one. This is the diameter. Okay? This is the RR length, and the RR length is 25. Okay? I think I have stick to this point. When making this one, I have made a mistake. Okay, I think I have stick to this one. I will delete. And reconstruct these lines again. Make this one again straight, vertical. It is still so. Give the dimension, which I have seen here, SS with 15. Also, I have an angle here. Also, I have another angle at that point, which is this one. These have 120. Also, this one, again, 120. Okay. The next thing, I have not fixed this line. I would like to have the midpoint on this line. Make coincident. Midpoint. I will go to midpoint on this line. Okay. Finish your sketch. Our next parameter is KK1. And this is the extrusion length here. I'll just change my view. I have the extrude tool. Select the two regions. I have changed my distance with symmetric extrusions. Okay? This is the one. Now, my first figure, it is finished. This time, I save my part file to desktop. A30. Okay, I will extend my inventor. So far, what we did in the part is stored here. We have the parameter set. Okay, from here, we have the fx tool, the parameters. What we did in the part is all stored at this point, as you see. We have the 100 millimeter in the dimensions, 30, 25, 15, the other degrees, or the kk length, which is this one. We have two ways. We have add a parametric as we wish. For example, we can add AA or LL parameter by manually. This is the user parameter. This is the model's parameters. I can have this one. As you see, it is in length, which is millimeter. And I will link this LL parameter, which I have seen the D0. I will make equal this one to D0, which is this one. When I have just made the done and turn back to fx, as you see, we have linked our parameter to this one. You can change the parameter here with D0, or you can just delete this one and name it as LL parameter. I'm going to change the DD parameter here. I will adjust. The 30 millimeter, from the first row, we have the DD parameter. The dimension, I have named that dimension, which is DD. This is case sensitive. If you use the capital DD, it means another thing. If you have another thing, please, these are case sensitive. The parameter is parameter. Okay? For 25, we have the capital RR for the radius at this point. Rename. The next thing, we have the 15, which is SS, straight side. The next, we have an angle, and it is not changing. It is a normal parameter, and it is not in the table. Also, the other one, the other dimension, it is the same. Again, these are degrees, and it is the same. But we, at the extrusion dimension, we have a KK length. This is the extrusion distance. I will change this one KK. And done. So, what we did, I have just created, made the parameters. You can also, while if you have the dimension parameter name, as you see, this is the DD. Look, what I have changed is, I have changed this name, and also I have changed the dimension name here. This is the LL. Also, when you look from here, this is the LL length. Okay? The next, what we are going to do is, I will save my part file. The next one, what I'm going to do is, I will go to Manage tab. And here I have an Ipart. Please click this one. Click Manage first, then Ipart. As you see, we have the table here, parameters. And I would like to have other parameters here, which is 40, 50. For this, I will just select first, then right click and insert 2 rows. The member, as you see, the member here have different names. You can just double click and edit with A40. It will warn you, you are going to change the member name. Just continue. Again, you are going to change the member name. You may have a warning that you are going to change. Okay? Also, you can change the part number to be seen on the assembly side. You can change these part numbers. This is A4, this is A40, this is A50. I will change the entries. The next, what we are going to do is, I will just satisfy this table as I have in the question. The first one, the LL is 100, the next 150, and the other one 200. I will change the dimensions. 150, the next one 200. The next step, I have 30, the DD, the second one 35, the second one 40. The next one, we have RR, as you see. You can also move up and down by changing the key parameters if you want so. You can take it back and take it again. For RR, we have 25, or SS, let's say. This is 15, 20, and 25. The KK, the extrusion length here, 5, 8, and 10, respectively. The RR, which is 25, 30, and 40. If you have a creation problem, you can verify your tools. Okay? First verify, then okay. When you do that, you may have a table on the left corner side of the feature window here. If you have made the assembly modeling right, you can just switch between the parts through this table. Okay, the next thing we have add this table. Also, with right click you can edit, or you can just have the create Ipart command. Now I would like to add some properties to my branch here. First of all, I would like to change the color. I will go and assign the red color. As you see, we have this red color. The part here have the red color as it is written. I will right click and edit this table by adding another property. I will just type the color of the part from the other tab. To here, I will add the value, which is renk in Turkish, the color. And I would like to just have this column to change the appearance. Please select the column first, right click, then the appearance. I would like to just change my properties, the color properties of this one. What I write here, I would like to have the change in the color properties. From here, I would like to have A30 within the red color. The second one, I would like to have in pink color. The third one, I would like to have in white color. Okay? When you have done this one, please verify. If you have a problem in this column, the color here, you cannot verify that one. For example, like this. Or you cannot get the color as you wish. Okay? When you change the property or the appearance here, we have the pink property. As you see, my part is right now pink on the top side. The next one, I have the white color. Also this one and this one. Okay? The next thing, I have the white part. Okay? Again, the default. The next thing, I have the default. For other properties, you can also add another properties, which is material property. This time, I would like to have this column affects the part material. I will change with the material of our part with the material column properties. Add a new value with the parameter and select with right click and change the material with, again, left click. As you see, we have a round icon here, and I will just write the properties. I would like to have the first one with steel properties. The second one, I would like to have stainless steel properties. The second one, I would like to have brass properties. Okay? When you just click verify or OK, as you see, we made a mistake, potentially damaging the errors in the table detecting materials say brass. Probably there is no brass material. As you see, the second one, we have the stainless steel. The first one, we have the material. When you just click this one, as you see, it is changing steel from the top side. The second one, I'm just going to edit and find a new material for the last one. Accept. I will just go to Autodesk material properties. First change the edit the table. Again, it is still no problem so far. I will change. This one. Go back to again. Here I can change the material. For example, from here, I would like to change another material from the bronze, let's say. I will close. I will change my material to bronze. Hit OK. I will go and change. When I go back here, as you see, my material is changing to bronze. Okay. We can also add some other properties like an on and off. For example, I would like to have the fillets in A30 and A40 at the Okay. You can also change some properties like on and off. For example, I would like to add for A30 a fillet property like this. Let's make it bigger to just realize like this. Also on the other side. Let's make 20 to see better. I have A30 at A30 range. I have the radiuses. Okay. With double click on the table, edit this table, I would like to add some parameters here, like the suppressed and unsuppressed. I have the parameter tab, then I would like to have the features. I must have this extrusion feature because otherwise I cannot have the part. But I would like to have an option to select the fillet command. I would like to have A30 and A50 with the fillets at these points, but I do not read at 40. I would like to add this fillet property to this table by selecting this command. From here, I have another column here, which is just says that I have computed this fillet property in all sections. But I would like to have not to be computed on A40. For this, please write not compute and click OK. No compute, I'm sorry. I have computed in two sections. Okay, edit this table and delete this one and verify as it is. Open a new part for this example. Open a new part. With standard millimetric. As you see, our part is symmetrical on two sides. One, we have a symmetric around y-axis. This is the axis. Also, we have another symmetry on x-axis. For this, I have opened an origin with center point and xy plane visible. And I will just accept this point as my origin. Start a new sketch on XY plane. I will create this time, because I'm going to use the mirror commands, two lines, two arbitrary lines for axis purposes. I will convert these two lines to construction and stick the midpoints to origin point. And these refer to these two axis lines. Have the constraint, coincident constraint, select midpoint of this line and stick to origin. Midpoint of this line, stick to origin. Okay. The next thing, as you see, we have this leg on this side and the other leg on the other side. For these purposes, I will just draw this outline like this. I would like to draw an outline, something like this. I have straight at this line end, and this line starts from the other side of the line. Delete this one. Again, have the line command. For representation of this line, it is this line. And after this line, we have a curvature. Stick to it with this property. And after that, we have another straight line. I will just go and make a smaller one. After this point, I will go straight. Then I will go a curve to top side. I made first tangent this line to this curve. Okay. The next thing, I have this curvature which is tangent to this line. Again, tangent, constraint, make tangent to this line. And after this point, I will just stick and go to the top side. A line which goes to top side, and after that one, I will go to the left side and do the same things for other pieces. But before, I would like to have the tangent constraint and make some clearance at this point. Şimdi temizlik yapıyorum. Trim for unnecessary parts. This is my first leg at this point. I will create the other leg on the top side. Okay? For here, I go a straight line to the top side. Do the same thing for other side, which we did here at these 2 points. Okay? I start this circle somewhere here and stick to this point. I will start a new circle somewhere here and make tangent this circle to this line. Also, I need another straight line for top side here and make the tangent for 2 circles and make the trims. Also for other sides. Make the excess trims. The next thing, what I'm going to do is, I will use the equality constraints for curves and symmetric constraints for lines. I will use the equality constraints. These 2 curves are equal. These 2 curves are equal to. Okay. The next thing, I will use the symmetry constraint for this S dimension. I have the constraint, symmetry, right click, this line and this line, symmetric around this line, the line on the middle. Later, the symmetric condition. Symmetry, this line and this line around this line. The next, symmetry is above and the bottom, top and the bottom lines are symmetrical around this x axis. Symmetry, this line around the line on the middle. Okay. The next, I have H, B, S, and T lengths. Also, I have some equalities, which is R1 equals to T and R2 equals to T, because it is divided to 1. Okay. The next, we first have the maximums lines here. Also, do not forget this one. The lines are symmetrical. First, the S dimension, not to move B sides. First, give the dimension. This time, I will do something special. With S, I write, this time I define the dimension with equal to 4 millimeter. S equal to 4 millimeter for profile 30. Again, I will define from the parametric side. This time I will change the parameter to S. Okay, afterwards. The next, I have the T1, which is 4.5. The T1, 4.5. Again, 4.5. But this time, I will use an equal sign to this dimension. I will stick that dimension. Okay? The next, we have the H profile, which is 30 millimeter on each side. That is 30. The next, we have the B length, which is 38. I will define 38. And make the equal this line to this line, because it is equal to each other. These two lines are equal to each other. Again, for radiuses, I will define the dimensions and make equal to this or this one. I will make equal this dimension with equal sign to this one. Okay? I have defined and fixed these two dimensions, these two curves. Also, these two curves are also defined because we have an equality constraint. The next, we have open and missing part. I will just move and stretch to this point by clicking here and make the trim to have the profile. You can change the parameters from here, which is this one. It is S, the second one. Okay. You can just change the dimension to SS. S means something different in inventor side.